Hey guys, today what we're going to do is we're going to do some basic review of adding and subtracting integers and fractions, and we're also going to be working on multiplying and dividing them as well. The most important thing for today's lesson is that there is no calculators that are allowed. Now when it comes time for homework, I'm not there to stop you from using a calculator, and I'm totally okay with you using your calculator to check your final answers, but just be aware there will be a homework quiz next class period where you are not allowed to use your calculator. So we practice like we play the game. If you can't use your calculator on the quiz, I suggest you don't use your calculator on the homework. So first thing we're going to talk about is adding and subtracting integers. Now, the main thing here is looking at the difference of the signs. If the two numbers that you are adding have the same sign, so either they're both positive or they're both negative, then we're going to add the absolute values of the numbers together and attach the common sign. So here's what that means. We're going to look at just the numbers, and we're not going to worry about the signs until the end. For example, number 3. If you'll notice, both of these numbers are negative. They have the same sign. So we're going to look at just the numbers 2 and 6. We're going to add them together. So 2 plus 6 is 8. And then we're going to attach the common sign. So since they're both negative, our result will be a negative 8. Again, on number 1, we have a 3 plus a 2. They both have the same signs. So we're going to look at just the numbers 3 and 2, add them together, and get a 5. And now that we have added them together, we're going to attach the common sign, which is a positive, so it's a positive 5. Now, when you have different signs, which means when you have a positive being added to a negative, what you want to do is subtract the absolute values from each other. So here's what's going to happen. You're going to look at number 2. We have a negative 4 plus a positive 8. I want you to look at just the numbers, a 4 and an 8. And since they're different signs, we're going to subtract it. We're going to take the bigger one minus the smaller one. So I want to take 8 and subtract 4, which is 4. And then we're going to attach the sign of the term with the larger absolute value. So if I look at just the numbers 8 and 4, 8 was bigger and 8 is positive. So my result will be positive. Now let's look at number 4. Number 4, we have a positive plus a negative, 8 plus negative 2. So I want to look at just the numbers since they're different signs, and I want to take the bigger number and subtract the smaller number. So 8 minus 2 is 6. Now I want to look at the signs. The bigger number, which was 8, has a positive sign, so my answer will be positive. Now on number 5, this one's a little easy. It's 6 minus 1. We all know what that is, but what I want us to do is get a little bit of practice in rewriting this, because we are much better at adding numbers than we are at subtracting numbers. So instead of saying 6 minus 1, I want us to rewrite that as 6 plus negative 1. Now we can use our method of same sign or different sign. 6 and negative 1 have different signs. So what I want to do is I want to subtract the two numbers. So 6 and 1, the bigger number is 6. 6 minus 1 is 5. Attach the larger sign. 6 was positive, so it's a positive 5. Now obviously we knew that 6 minus 1 is 5, but that's just the method that we're going to go. It's going to make things a little bit easier down here. On number 6, if you will look, we have a negative 3 minus a 4. Now I want to rewrite that again as a negative 3, and instead of a minus I want a plus, but that minus sign still has to go somewhere, so we're going to go negative 4. So I have a negative 3 plus negative 4. Now, negative 3 and negative 4 have the same sign, so here's where I want to add the two numbers together. So 3 plus 4 is 7. And then attach the common sign, so negative 7. On number 7, again, we need to rewrite that as negative 7 plus negative 3. And here, if you'll notice, I'll have the same signs, so we want to add the numbers. 7 plus 3 is 10. Attach the common sign, and we get a negative 10. On number 8, we have a 3 minus a 7, so we want to rewrite that as 3 plus negative 7. Here they have different signs, so we want to subtract the numbers, so just the numbers, 7 and 3. Take the bigger minus the smaller, so 7 minus 3 is 4. And then attach the sign of the larger number. So 7 was the bigger number, 7 is negative, so we have a negative 4. Alright, what I'd like you to do is pause the video, do number 9 and 10 on your own, rewrite them if you need to. Okay, so on number 9, hopefully you rewrote that as 4 plus negative 5, and you should have gotten a result of negative 1. And on number 10, we don't need to rewrite that. We have different signs here, so 4 minus 3 is 1, bigger number is negative, and again we get negative 1. Alright, next we're going to talk about multiplying integers. Now you guys should be very good at this. You've been doing this for a while. Just a reminder, if you're multiplying two numbers with the same signs, you're going to get a positive result. So a positive times a positive is a positive, or a negative times a negative is a positive. And if you multiply two numbers with different signs, your result's going to be negative. So a positive times a negative will be a negative, or a negative times positive will be negative. So on number 11, I'm going to focus on just the numbers first, then deal with the signs. So I have 4 times 3, which I know is 12. And I have a positive times a positive, which I know is positive. On number 12, I have a negative times a negative, so I know my result's going to be positive. And a 5 times a 2 is 10. On number 13, I have a positive times a negative, so right away I know my answer is going to be negative. Now let's focus on just the numbers. 6 times 2 is 12. On number 14, a negative times a positive, so I know it's going to be negative. 3 times 7 is 21, so negative 21. And then on 15, I have a negative times a negative, which I know will be a positive, and a 4 times a 4, which is a 16. So the important part here is I handle the signs, I make sure I double check my signs, and then I go for the numbers. So please pause the video, do the next 5 completely on your own. Alright, on number 16 you should get a negative 14. 17 you should get a negative 24. 18 you should get a positive 16. 19 you should get a positive 35. And 20 you should get a positive 42. Alright, next we're going to talk about adding and subtracting fractions. To add and subtract fractions, you must have a common denominator. Now, just a refresher. A denominator is the number on the bottom of the fraction bar, and a numerator is the number on the top of the fraction bar. We are in high school now. We do use denominator and numerator. We do not use top and bottom. So, to get a common denominator, you need to look at what you're given. If you do not have a common denominator, you cannot add them together first. So on number 21, I have 1 over 5 plus 3 over 5. So 1/5 plus 3/5. If you look at the denominators, they are already the same. So what that means is we can go ahead and add them. Now when adding fractions, this is really important, you cannot add the denominator. The denominator stays the same. So since it's both 5, my denominator will be 5. Now the numerators, 1 plus 3, that gives me 4. Now, before you move on, our final step is you always need to check to see if your fraction can reduce. So 4 over 5 cannot be reduced. That is our final answer. On number 22, again, I have 4/9 minus 2/9. If I look at the denominator, the denominators are the same, so I can go ahead and add, well, I'll subtract them. So let's talk 4 minus 2. I know that the 9s has to stay the same, so the 9 comes down here. 4 minus 2 is 2. Now let's double check. 2 over 9 cannot reduce. On number 23, I have a negative 2/5 plus 3/5. Now they're throwing in negatives here. That's no big deal. It's just going to be the same. So let's start with the denominator. I have a denominator of 5. That can come on down. Now let's look at the numerators, negative 2 plus 3. This is when we can think back to what we did at the top of the page. Same signs or different signs. Negative 2 and a positive 3 have different signs, so I need to subtract the two numbers. So 3 minus 2 is 1, and attach the sign of the bigger number. So 3 is bigger than 2. 3 is positive. My answer is a positive 1/5. Finally, before you move on, check to see if your fraction can reduce. 1 over 5 is fully reduced. On number 24, I have 1/3 plus 5 over 6. Now, those do not have a common denominator, so what I need to do is I need to make them have a common denominator. So I'm going to look at the denominators of 3 and 6, and the first thing I want to check is if one denominator can go into the other. For example, 3 is the smaller one here. Can 3 go nicely or evenly into 6? And the answer is yes. 3 can go into 6 2 times. That means I want to take this fraction and multiply it by 2 over 2. And the reason that we need to do that, if I multiply this by 2 over 2, if my pen would work here, if I multiply that by 2 over 2, if you look at the fraction 2 over 2, it's actually not reduced. It would reduce to 1, and we know that anything we multiply by 1 is itself. So we're not actually changing this fraction, we're just manipulating it to make it do what we want. So if I multiply this fraction of 1/3 by 2 over 2, I'm essentially just changing what it looks like to make it work for me. So when I do that, I'm going to put an equal sign over here, and I'm going to rewrite what I have. So 2 times 1 is going to give me 2 in the numerator, and then 2 times 3 is going to give me 6 in the denominator. Then I'm going to bring over what's left, so I still have the plus 5 over 6. And now I can look at what I'm given, and we can see that I actually do have common denominators now, and I can add them straight across. So 2 plus 5 is 7, and then bring down my common denominator of 6. Now we need to check to see if our fraction can reduce. 7 over 6. I understand that this is an improper fraction, and at the middle school level I'm sure that you guys worked on turning improper fractions into mixed numbers, but here at the high school we like improper fractions. We do not like mixed numbers. Please do not turn that into a mixed number. Leave it as 7 over 6. Now I still want to see if it can reduce. Do 7 and 6 have any common factors? No, they don't, so this is our final answer, 7 over 6. Now, just reminding you, please do not turn it into a mixed number. If you turn it into a mixed number, I will count it wrong. We need to leave them as improper fractions. On 25, I have 7/10 minus 3/5. Now, they do not have a common denominator, but I'm going to check to see if one can go into the other. So 10 and 5, I know that 5 can go into 10 2 times, so that means I need to take this fraction right here and multiply it by 2 over 2, and that's going to give me a new fraction. Now I'm going to rewrite my new equation. 7/10 did not change, minus my new fraction is 3 times 2, which is 6, over 5 times 2, which is 10. Now I can easily subtract those two fractions. I have a common denominator of 10, and then in the numerators, 7 minus 6 is 1. Now 26 is a little bit different. If you'll notice, 26 is negative 2 over 7 plus 4. Now 4 is not a fraction as it is written, because we're a little confused. I mean, they have to have common denominators, and 4 doesn't even have a denominator. However, 4 does have a common denominator, and that denominator is 1. Any integer can be rewritten as 4 over 1, and that means I now have a fraction of negative 2/7 plus a fraction of 4 over 1. To get a common denominator, I need to look at what I have. 7 and 1. The smaller denominator, which is 1, can go into 7 exactly 7 times. So I need to multiply 4 over 1 by 7 over 7 to turn this denominator into a 7. And when I do that, I'm going to get negative 2/7 stays the same, plus 4 times 7 is 28, over 1 times 7, which is 7. Now I can add those two together. They have the common denominator of 7, and negative 2 plus 28. Now, same signs, different signs. They have different signs, so I need to subtract the two terms. So 28 minus 2 is 26, and attach the larger sign. So the larger sign here is positive. I have a positive 26 over 7. Now, let's see if this fraction can reduce. I understand it's improper. Remember, we leave it that way. So 7 is a prime number. The only numbers that can go into 7 are 1 and 7. So 7 cannot go into 26, so we cannot simplify this fraction. All right, on number 27, I have 2/3 plus 3/4. So I have a denominator of 3 and 4. Now let's see, can 3 go into 4 evenly? It cannot, which means that we can't just multiply one fraction by a number and call it good. This is when we need to look for what's called the least common multiple between the two. So if I were to look at my two denominators of 3 and 4, I would want to think of what's called their multiples. So like if I want the multiples of 3, I know that 3 times 1 is 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. And then I would want to look at the multiples of this denominator here, this 4, and I would want to list those out. So the 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Now what we want to do is we want to see what is the smallest number that both of those lists have in common. And as you can see, that number is 12. So that's what we call the least common multiple of 3 and 4. That means we want to turn each of these denominators into a 12. That's going to be the least common denominator between them. So if I look at my first fraction of 2 over 3, I want to think, okay, how do I turn a 3 into a 12? And if you'll remember, we multiplied it by 4. So that means I want to multiply 2/3 by 4 over 4. Now this fraction over here, 3/4, I want to turn this denominator into a 12 as well. So to turn a 4 into a 12, we have to multiply it by 3. So that means my second fraction, I need to multiply by 3 over 3. So let's see what I get when I do that. So my first fraction, 4 times 2 is 8. 4 times 3 is 12. Plus 3 times 3 is 9. 4 times 3 is 12. Now this is the new equation that I want to work with, new expression that I want to simplify. They do have common denominators, so since my common denominator is 12, I can bring that down here. And now I can just add my numerators. 8 plus 9 is 17. Double check to see if that can reduce. And it cannot, so I have 17 over 12. Now on number 28, I have 2/9 minus 3/2. Now 2 cannot go into 9 evenly, so we're going to have to, again, find the least common multiple. Now on number 27, we listed out the multiples of each number and went from there, but there's actually an easier method. If you take these two numbers and multiply them together, that usually gives you the least common multiple. If not the least common multiple, sometimes it gives you a multiple. So just be careful because sometimes you might need to simplify at the end. So 2 times 9 is 18. That means I want to turn 2 over 9 into something over 18. So that means I have to multiply this 9 by a 2 over 2. And this fraction over here by a 9 over 9. And let's see what happens when I do that. So 2 times 2 is 4. 2 times 9 is 18, minus 3 times 9 is 27, and 2 times 9 is 18. Now, we know that the common denominator is 18, and in the numerator I want to take 4 minus 27. Now here's where things can get a little tricky. If we're working with 4 minus 27, 4 is smaller than 27, which makes it a little hard. So that's when I want to rewrite this as an addition problem. So instead of saying 4 minus 27, what if I say 4 plus negative 27? Now that turns it into same sign, different signs. We have different signs, so I want to take the bigger number minus the smaller number, which is 23, and attach the larger sign, which is negative. Double check to make sure that can reduce, and box your final answer. Alright, what I'd like you to do is pause the video, do number 29 on your own. All right, hopefully you multiplied your first fraction by 4 over 4 and your second fraction by 7 over 7 to get 8 over 28 minus 21 over 28, which I changed to plus a negative. And when you add those together, you should get negative 13 over 28, which does not reduce. All right, next what we're going to talk about is multiplying fractions. Multiplying fractions is very easy. All we have to do is take the numerator times the numerator and put it over the denominator times the denominator and double check that we don't have to simplify. So on number 30, I have 2/5 times 3/4. Again, numerator times numerator. So 2 times 3 gives us 6 over denominator times denominator. 5 times 4, which is 20. Now let's check to see if that can reduce. 6 over 20. Well, both of those numbers are even, which means that 2 can go into both of those numbers. So let's divide each one by 2. If I divide my numerator by 2, I get 3. And if I divide my denominator by 2, I get 10. So these fractions are actually equivalent. If you were to put them into the calculator and get a decimal, you would get the same result. But this answer is the correct answer, because if we leave it like this, that's like writing your name without capitalizing your letter. It's not, you're the first letter. It's not complete. You need to simplify it all the way down. So 3 over 10 is our final answer, and we can box it. On number 31, we're going to take numerator times numerator. So I'll have 1 times negative 3, which is negative 3, over 2 times 7 in the denominators, which is 14. Double check to see if it can reduce. 3 cannot go into 14, so we are good to go. On number 32, numerator times numerator, negative 5 times negative 2 is a positive 10. Denominator times denominator, 6 times 7 is positive 42. And let's see if this can reduce. So 10 and 42, a 2 can go into both of those. So 10 divided by 2 is 5. 42 divided by 2 is 21. Box your answer. And 33. On 33, I have 1/5 times 8. Remember, any integer like this can be rewritten as a fraction, as 8 over 1. Now, please take numerator times numerator, and we get 8, over denominator times denominator, and we get 5. Now, do not turn that into a mixed number. We want to leave it as an improper fraction. Finally, we're going to talk about dividing fractions. Now, here's what's tricky about dividing fractions. In fact, when you talk about dividing fractions in mathematics, we never actually divide fractions. Instead, what we do is we multiply by the reciprocal. So, on 34, I have 2/5 divided by 1/4. We don't like that. So what we're going to do instead is we're going to leave the first fraction as it is, 2/5, 2 over 5, if that would write correctly. And instead of divide by 1 over 4, we're going to change that to a multiplication problem. And we are going to find the reciprocal of the second fraction. Now what that means is we're just going to take this second fraction and we are going to flip it over. Whatever was in the denominator is now in the numerator, and whatever was in the numerator is now in the denominator. So 1 over 4 is actually 4 over 1. So 2/5 divided by 1/4 is the same thing as 2/5 times 4 over 1. Now we can multiply those two together. So 2 times 4, numerator times numerator, is 8, over 5 times 1, denominator times denominator, which is 5. Check to see if it can reduce, and box your answer. On number 35, again, we need to rewrite it. So my first fraction stays the same, negative 2 over 11, times the reciprocal of my second fraction. So 7 over 4, we need to flip that around to 4 over 7. Now we can take numerator times numerator. Negative 2 times 4 is negative 8, over denominator times denominator. 11 times 7 is 77. Now, to check to see if this one can reduce, both of them are not even. So one's even, one's odd. We can't put a 2 into it. Let's see what else. A 4 could go into 8, but can't go into 77. 8 can go into 8, but also can't go into 77, so this is our final answer. On number 36, again, we need to change this into a fraction, so I have 3/5 divided by 7 over 1. And then we're going to rewrite this. So I want you to pause the video and rewrite this on your own, please. Hopefully, you got 3 over 5 times 1 over 7. Now we can take numerator times numerator. 3 times 1 is 3. Over denominator times denominator, 5 times 7 is 35. And we cannot reduce. Now, 37 is written a little funny. It's kind of hard to see there. It's 3/5, and then there's like another big fat bar here, and then 4/7. Now, a fraction bar is just another way of saying divide by. So if I have 3/5, that's actually a way of saying 3 divided by 5. But we want to leave it as a fraction for now. What fraction bar we do want to change, though, is this guy here in the middle. So we can actually rewrite this guy as 3/5 divided by 4/7. Now that it's easier to read, we can rewrite it as multiplying by the reciprocal. So 3/5 stays the same. Divided by turns into a multiply. And 4 over 7 can turn into 7 over 4. Now, please pause the video, multiply those together, and reduce your fraction if it can be. All right, hopefully you got 21 over 20, which cannot be reduced, and is our final answer. Now on 38, let's rewrite it. I want my first fraction, the one in the numerator. I have 1/2 divided by the fraction in the denominator, 3/8. Let's rewrite that as 1/2 times 8/3. And now we can take numerator times numerator over denominator times denominator. Check to see if it can reduce. 8 and 6, oh, those are both even. So a 2 can go into both of those. 8 divided by 2 is 4. 6 divided by 2 is 3. And our final answer is 4/3. Number 39, let's start by rewriting it. Negative 1 over 4 divided by negative 2 over 3. Now we want to rewrite that as a multiplication, so negative 1/4 stays the same, times the reciprocal of negative 2/3. Well, the 3 is going to go on the numerator, the negative 2 is going to go on the denominator, but here is what is really cool. When you are working with negative signs and fractions, it actually doesn't matter where you put the negative sign. For example, negative 5 over 6 is the same thing as 5 over negative 6. The negative symbol does not matter. It does not matter where it goes. In fact, I could have it in the numerator, the denominator, or if I wanted to, I could have it right out here in the middle in front of the whole thing. That's the same thing as negative 5/6. So when you're dealing with a negative symbol in a fraction, it's actually able to move wherever it's most beneficial for you. So here I have it in the denominator, but I know that if I take a negative times a negative, it's a positive. So for me, it would be more helpful if my negative symbol was in the numerator. So I'm just going to move it up there because that's going to be easier to work with later on. Now I can take my numerator times numerator. A negative times a negative is a positive. 1 times 3 is 3. Over my denominator. 4 times 2 is 8. All right, there you have it. Your homework is due next time. There will be a homework quiz.